And we will talk about different applications first, and then we talk about these applications in particular. We talk about how HTTP works, how file transfer, email, DNS, and P2P works. And so, since these chapters are rather big, we are going to have many intermediate points in these chapters. So, first module in this chapter is network application architecture. So, we will talk about what are the different protocol layers, what does P2P mean, what is process communication, what are the names, addresses, and ports, and what are the transports. So, protocol architecture. We already know that TCP/IP has a stack, has a layer stack, or layers. So, we have the physical layer, then what was called data link layer, it is called host to network layer. Now we generally call it data link layer. IP is the internet layer, and then transports are TCP and UDP. For applications, we have HTTP, FTP, SMTP, P2P, DNS, Skype, and so on and so forth. These are all applications. So, in this chapter, we are going to talk about only those things on the top. We are not going to talk about much of this. So, the applications could be two types, either client to server or peer to peer. Client to server is where there are few servers and all the clients reach to them. Okay? So, when you go to Amazon, what kind of application you are using? Client to server. Actually, when you go to any web page, you are using client to server, because there is a web page server and you are a web page client. Right? So, this is the original architecture. That is what most of the time, except for 10 or 15 years ago when P2P started, until then this was the common thing. We used to have servers and clients. Then they figured out that P2P is also possible. So, actually web servers, search engines, Google, social networking, Facebook, these are all client server applications. Right? But then P2P started. In that case, we don't really need a server. We can just exchange files among hundreds of us together. Right? How many of you have done P2P? You don't have to be shy. I mean, this is just another method of transmitting information. And it is not always illegal either. In fact, there are legal ways of transmitting information. P2P is better in many cases. So if you want to distribute a software for whatever reason, you can just put it on P2P and be done with it. You don't need to maintain a server or anything like that. Right? So anyway, so P2P is used a lot for illegal activities, but it's also done for legal activities. So anything actually is much faster to get by P2P than to get it from the server. So that is P2P. File sharing, BitTorrent, Emule, LimeWire, etc., etc. Now Skype is also P2P. Okay, so we'll go into Skype, and in Skype, when you're talking to somebody else, you might be talking to somebody else's computer, and so on and so forth. And the advantage of P2P is that it is highly scalable. Servers have a limited capacity. So if a server is designed for 1,000 people, if you have 2,000 people, server is gone. But P2P, there is no limit. Okay? So highly scalable, highly symmetric traffic, ISP unfriendly. Now the problem with the P2P is that the ISP networks are not really designed for P2P. So when they give you 18 megabits, they hope that you will use only 2% of the time, right, or 1% of the time. So they sell it to 100 people, 18 megabits, and the total capacity of 100 megabits they have. If everybody started doing P2P, which means they are continuously downloading at 18 megabits per day, they are in trouble, right? They cannot support it anymore. So they like to discourage it. So it's not very ISP friendly. ISP is Internet Service Provider, right? Difficult to authenticate. Now second thing is you don't really know where you're getting the information from and whether the information is good or bad. There's a lot of garbage out there. And need incentives here. Everybody wants to download, nobody wants to upload. Right? As soon as you download it, you log off, and done with it. right? So the question is, how do we make sure that people remain up even when they don't need anything, just for other people, right? So that's something. All right, we'll talk about that when we come to P2P. But now at least you understand two things, that there is two ways to distribute information. One is by servers and second is by P2P. Now, another concept you need to know is when you program a computer to do anything in Unix, then that is the mother of all operating systems. In Unix, they had sockets. So when you want to talk to another process, you had sockets. You just open a socket to that process, and then you write to the socket, read from the socket. So that's how most of the applications work. When the networking came around, the process does not have to be on your computer. It could be on some other computer. And so when you do any networking, you just write to the socket, and the socket sends it to TCP/IP protocol stack, and then TCP/IP protocol sends it to the other computer where the socket gives it back to them. All right. So whenever we use the word socket, most of you already know it, but basically this is the operating system interface for process-to-process communication. All right. Then we use the name. Actually, we have already talked about the names and addresses. So I think the only thing we haven't talked about is the ports. So every computer has an address like this, and every computer could have a name. It doesn't have to have a name, right? So every computer could have a name, and so we can use DNS to translate the name into address. So there are servers to which we call DNS servers, domain name servers, to which you give the name and you get the address. And the address is what you need in really to get there. So for example, if you just said my name Raj Jain, you won't be able to get to me. But if you know my address, you could drive there. Right? Similarly on the network, you need my computer's address to talk to it. Right? So the address is finally we need. Now remember, these addresses, you might have already noticed it, but these are always 4 decimal numbers. So 209 is not hex. 209 is a 209 decimal number. Second thing, these numbers are always less than 256. So you will never find 256, you will find 255 maximum. 0 through 255. So there are 8 bits. All right? And there are 4 of them. So you have 4 times 8 bits, there are 32 bits. So the IP needs 32-bit addresses. It doesn't really read decimal or anything, it just needs binary. It needs 32-bit binary numbers. Right? And since human beings cannot remember binary, they said, why don't we just write the numbers in decimal and write 4 decimal numbers that way? And so the program then can translate that into 32-bit binary number inside the computer. So when you see a packet on the net, if you were able to see a packet on the wire, you would see 32 bits of binary numbers of whatever you address you're trying to send. Now, every computer has many applications, many processes running. So how do you find which process you want to talk to? So every process has something called a port. So if you want to talk to a particular process, you give its port number. So, for example, if you want to talk to a web server, all the web servers generally use port 80. So you talk to port 80 on a computer, and if there's a web server, sorry, every time I go up, remind me again. So every time so 80, if you send to some computer and say, I want to talk to port 80, it will connect to the web server. If you connect to 21, that is FTP. Some of you know already, right? FTP. So every application has a port number. These are called well-known ports. You don't have to use 80 for web serving. You could have a web server which talks on port 81. In fact, in my home, I have 10 web servers. Why 10 web servers? Because I have one camera which has port number 81, another camera which is port number 82, another camera which is port number 83. All of these are web servers. All of them can be accessed by the web. I can log into any of the camera, I can see anything, right? So what do you do? I mean, you cannot have 80, all of them, right? So you do different port numbers. But there are well-known port numbers, which are generally, if you don't know any better, then just use the well-known port numbers. Okay. So this is like port. So this is like a country, and then you want to get into, then you have to know which port you want to get into. Similarly, in a computer, there are processes, and you want to know which process you want to get into. You have to know what port number you want to get into. All right. When we go into the detail later on, we will find out that the ports are really, they belong to the transport service, to the TCP and UDP, and the addresses belong to IP. So this is layer 3 addressing, and this is layer 4 addressing. These port numbers are layer 4 addressing, and the port numbers are 16-bit long. 16-bit long, so the maximum port number can be 2 raised to 15 or 16 minus 1, something like that. 0 to 2 raised to 16 minus 1, 16,000 something. All right. So before we get into applications, we just need to tell you about two transports we use, TCP and UDP. TCP is used for reliable data transfer. In TCP, whenever you send a packet, the acknowledgement comes back. So when you send a packet, you get the acknowledgement that I got the packet. And so it is reliable. If somebody does not get the acknowledgement, you know that the packet did not make it, you time out and you resend it again. In UDP, there is no acknowledgement. You send the packet and hope that it got there. All right? So this is for unreliable data transfer, and this is for reliable data transfer. Each packet has a number. So when you get an acknowledgement, it says I got everything up to packet number 45. So you don't have to worry about anything up to 45. You can throw away your copy of them. They already made it to the destination. In this one, it is optional. Every packet is agged, every packet is not agged. I mean, no packet is agged. Last packets are retransmitted, there is no retransmission. It may cause long delays. So all of this is positive, but the negative is that if something gets lost, then you're waiting forever for the acknowledgement, and it can be, you may wait a long time. There are some applications that don't like that. What are those applications? Audio and video. I mean, if I said something, now if you didn't get it, are you going to wait until you receive it again, or you would rather go on and say, okay, let's send me the next word, what he said? All right, most of us would rather go on to the next word than then stop and then wait for the next, so on and so forth. So this is cause long delay, where it doesn't cause any delay that much, and so it is quick. So this is connection oriented service. So before you can do TCP, you have to set up a connection with the destination, and that's important here. Not like circuit switching. In circuit switching, you have to set up the connection through every hop. In TCP, we don't set up anything at every hop. We just set up with the end system. So if I'm talking to him at the corner, then I tell him that, look, I want to talk to you TCP. He says, yeah, go ahead, talk to me. Then I will say, here's my packet number 1. He says, yeah, acknowledgement for packet number 1, packet number 2, acknowledgement for packet number 2, and then I say, okay, disconnect. I'm done. All right? The routers in between don't know anything about this packet number stuff or anything like that. They don't care. They just know the source and destination. They don't know something is lost or not, anything like that. They don't care for any of that. But TCP cares. So the TCP is connection oriented, where UDP is connection less. Means you don't have to set up any connection. You could just send a packet, and that's it. So this is good for reliable and delay insensitive applications. This is good for loss tolerant and delay sensitive applications. So anything that can lose packets and not care about it, and in which delay is important, those applications use UDP, and those applications are telephony, streaming multimedia, and then on this side we have email, HTTP, FTP, RT, and remote terminal access, and so on and so forth. Yeah.
At what level is TCP or UDP specified? Like, is that the application level?
Layer 4. And so actually, once we are done with this chapter, the next thing would be TCP UDP, because we start from layer 7 and move down. So after application, the next layer is layer 4. And then we go to IP, layer 3. And then we go to layer 2, which is Ethernet. So that is the next chapter. Yeah.
So what does connectionless service mean?
Connectionless service means that you don't need to beforehand tell the receiver that I'm going to send you a packet. The connection oriented. So basically when we come to TCP, there is a packet that we send first. We send a packet. If I want to send you a big file, let's say, so I will just send you a first packet saying that I want to set up a TCP connection with you. And so you say, all right, go ahead, and here is the connection number and here is the sequence number. I mean, I will probably say that, okay, I will start my counting from 2000. The packet number don't have to start from 1. I will start from 2000. You say, okay, all right, I'm ready for receiving. Then I send you packet number 2000, you send acknowledgement back. So that first packet is called connection. And connectionless means that first packet doesn't exist. I could just send you a packet. It may have a sequence number, it may not have a sequence number. That's optional. I could just say, well, here's my voice. You could throw it, you could play it, and so on and so forth. There are many applications where UDP is very good. For example, if you are doing management of a network, so all the computers that are being managed, this is the managing, so I'm supposed to be managing server, right? All the computers that are being managed can send that, oh, I lost 2 packets, that information to me, and I can keep counting as to who lost what and all that. If some packets don't make it, that's fine. Okay, so there are many applications that don't care if the packets are lost. Those are connectionless UDP applications. Okay, you had a question?
Yes. So UDP, the sequence number is optional. So I can actually enjoy the speed of UDP and manage how much I want to lose at the application level.
Right. So let me understand your question. Your question is that sequence number is not there, so the application will have to decide how fast to send and how much to lose. Yes. Application is totally responsible because really there is no transport. I mean, UDP doesn't do much. All right. So now that you know the basics of the networking, now we can talk about the application layers. And we will go in this order: HTTP first, FTP second, and SMTP, and so on and so forth. So let's just go with one. Oh, before we go, let's summarize this module, which was the application architectures. So 5 things we talked about. First thing we talked about P2P versus client server. Which is more scalable? P2P. Scalable means many more people can be served with P2P. Second thing we talked about is that the application exchanges, when we talk about operating systems, the way we send the messages in operating systems, we send it to sockets. Right? We make socket calls. But in the case of networks, the applications have port numbers, and there are some well-known port numbers. And there are 2 transports, TCP and UDP. TCP is for reliability, and UDP is for unreliable protocols. And same thing said here. Basically, UDP is good for delay-sensitive applications. All right. So let's go to HTTP. And here we will talk about 5-6 things. First, we'll talk about what is HTTP, how does a sample web page written, what are the messages, what are the cookies, what are the proxy servers, what is a conditional GET. So basically, HTTP, Hypertext Transfer Protocol. P stands for protocol. Hypertext. So before there were web pages, there was hypertext. What was hypertext? In the old days, before 94, you could have a plain text, or you could have hypertext. In hypertext, there were some words that you could click on, and if you click on those words, it will tell you more detail about that word. Right? So that existed before. However, this guy whose name was in the previous slide, what is his name? Berners-Lee or something. Berners-Lee. He came up with the idea that when you click on something, it doesn't have to be on the same computer, it could be on some other computer. That was his innovation. So he extended hypertext from a local information to do global information. So now he said, oh, you can write a page and you click here and then you can reach that other place, get the information from there. So that is well, actually that is called hypertext. And now you write in a language called HTML. HTML is the language, L is for language. Hypertext, what is M for? Markup language. All right. So talking about the HTTP, there is a server, and when you want to get a page, you send a request, which is called HTTP request, and you get HTTP response. Somebody else who is running another computer could send an HTTP request and get an HTTP response. They could be running very different programs. This guy is running Internet Explorer, this is running Navigator, Firefox or something, doesn't matter. But all of them generate the same message. The interface, the user interface could be different, the operating system could be different, but the messages are exactly the same. So the server gets the messages and knows what you are requesting and sends you a response. Responses are very similar, are same, and then they are displayed on your computer according to your computer screen size, according to your whatever you have. If it is a little iPhone, it will be displayed differently than if it was a big 42-inch screen. So anyway, HTTP server is written by Microsoft or Apache and so on and so forth. And web page, now what is a web page? So web page itself is a whole group of objects. It could have some text, could have some pictures, could have some movies, all into the page, right? So we call them objects. These objects could be text, images, and files. And each web page has a URL. URL is the locator, Uniform Resource Locator. So that URL tells you where the page is located. For example, when you say http://www.csc473-11-2A CSE473 blah blah blah. This is a URL. You already know that. But what you should know now is that the first part here is the protocol. So to access this information, you need to use this protocol, not FTP. You could probably access something else with FTP, so that would be FTP : something. Second thing is, this is the name of the computer on which it exists. Third thing, this is the name of the directory in which the information exists on that computer. And this is the name of the file. Now, this first part is case insensitive. So you can write in uppercase, lowercase, mixed case, it doesn't matter. But this second part is kind of very confusing, because it could be case sensitive, could be in case insensitive, depending upon the operating system of the server and of the client. All right? So you just have to copy it exactly. Because if you type something, I type in lowercase and you type in uppercase, your operating system may say file doesn't exist. Okay? So the directory names and the file names are case sensitive, and the computer names are case insensitive, the protocol names are case insensitive. Yeah. Okay, because when you are reaching a computer, you have to tell it what computer you are reaching and what port number you are reaching, and what protocol you are going to talk to it about, right? So actually I am missing one thing here. I could have put here :80. After edu, I can put the port number. So that tells me that I want to reach this computer on port 80, and then I will, after I connect, now this you are telling to TCP, that after I connect, I want to talk HTTP, so then TCP will, now TCP is serving many applications in that computer. It is serving an FTP server, it is serving a web server, and so on and so forth. So it has to know which process to give your packet to. So that first word and the port number tells what protocol you will be speaking and what port number. Okay, so it is important to put that HTTP. Now, having said that, the browsers today are very smart. If you forget to write HTTP, they can fill in for you. As long as you write www, they know that www is generally for web service, so they will fill in HTTP :/for you. In fact, now, I mean, in this latest version of any of the browser, you don't have to write anything. You just write Raj Jain, and they will look up, they will do the Google search, and they will find it. And they will put in right there. But that is not part of HTTP as it is. It is just browsers are doing it for you. All right. So far, main thing was that you have to understand that HTTP is a protocol, and that you need a locator to get to the server, and then the web page. So now HTTP. HTTP is a protocol which uses TCP. So that is first thing to know, that it doesn't use UDP. Everything that is sent either direction is acknowledged. Yeah. Yeah, that's a separate connection. Okay, so we will come to, actually, the last chapter of this whole course is multimedia networking. So you have to wait until the end to figure out how video gets through. But for now, everything is TCP. Second important thing to notice is that the web server is stateless. So when you ask it something, it gives you the answer, but then it doesn't remember what you had asked and what the answer it gave. Second time you go to it, it doesn't know that you had already asked this thing or what it is, right? So that is the original design. The original design by Berners-Lee said that we will not keep any state in the server, and that makes the server really simple. All right? But later on, as we get to real world, we found out that the server needs to know that you have bought this thing and this is in your cart, and that, this is you, and so on and so forth. So then they started cookies business. So we'll talk about how the cookies work. But until we come to the cookies, the servers are stateless. So they don't remember about any request they served, anything. Third thing is non-persistent. Initially, when the servers were designed, they set up a TCP connection for every single object. So on a page, you have a text, you have a picture. Let's start with a simple page, text and a picture, and maybe 5 pictures. So there are 6 objects, text and the 5 pictures, right? So you will make 6 TCP connections. First TCP connection to get the text, close the connection. Second TCP connection to get the picture number 1. Third connection to get picture number 2. So that was called non-persistent TCP connection. Right? Soon we figured out that that's really waste of time. In the beginning it was okay because there were only one kind of objects and there were 1 or 2 objects on the page, but now the pages are very complicated and there are lots of objects, so there is no point in setting up a TCP connection for every object. Why don't we just set up a TCP connection and send 50 objects and everything that we need and then close it? So that is called persistent connection. All right, so non-persistent and persistent. So most of the recent implementations. So here the HTTP protocol has version numbers: version 1, version 1.1, version 2, version 3, version 4, version 5. Just like HTML has many version numbers: HTML version 4, 5, and so on and so forth. Right? HTTP is different, right? HTTP is a protocol. HTML is the language. So HTTP version 1.1 onwards, we have persistent connection. That means the server leaves the connection open after sending an object and only closes when you don't ask for anything more. If you don't ask for some time, then they close the connection. Web pages are written in HTML. So let's write a page. Here is a page. HTML, head end, and then body, image, jan.jpg, break, name, Rajan, body, slash name. This is a full page, right? If you write this page and you get it on the browser, you will get this picture and this name. Okay? And those of you who have not written HTML, this might be a good idea to write in HTML because it's so easy. There's nothing here except that the header and then the body and then these things, like image, source file name, and the text. Yeah.
So is that image retrieved in the same
Okay, so that depends upon the browser. As I said, if you have a browser which is very, very old, many people have programs which are 10 years old. I mean, who knows? If you are using HTTP version 1, then it will be retrieved in 2 sessions. If you are using HTTP 1.1, which is most likely if you have a computer which has Vista and Win 7 or something like that. If you still have Windows 95, that will do it in multiple sessions. But if you have something recent, it will be 1 session.
So given that Google is pushing asynchronous JavaScript where you keep on accessing the server even once you go to the page.
Yeah.
Is there any consideration for extending the session of that TCP stuff?
No. So thing is, I haven't gotten into that detail, and I would not get into that detail what Google is doing. But whenever they put it where you have to ask for many times, I'm sure that they would do persistent connection, which means they would allow you to keep, and the timeout would be such that, if you don't use it for 1 minute or something, then they will time out. So, and that is all Google specific, and I will not go into that one. All right, but for general case, for HTTP protocol as defined, HTTP version 1.1 actually allows and uses persistent connections. Okay. Now, even though it is a persistent connection, the timeout is up to the server. Some servers are so busy that they will time out very fast. Some servers have nothing to do; they will just keep you alive for days. And some servers keep you alive for days just because they want to. Like Amazon. You go to Amazon, buy something today, don't complete the purchase, come back 3 months later, it is still there in your cart because they find it is useful to them. Whereas you go to some other website and you buy something and come back 1 hour later, the cart is empty. Right? So it's all their choice, and we cannot justify any particular person's choice, right? So anyway, so the idea is you can write a web page, and you should write a web page. In fact, if you take any other networking course after this, we will force you to write a web page. Because that is minimum requirement. And so basically everything that you do today is a web page. When we write a paper, it's a web page. In my website, I have 60,000 web pages. Right? So I got to do this full time. And so this is your life, basically. Okay, all right. So now you know what web page. The idea of giving this is that there are 2 objects here, the text and the picture, and then there's a whole markup. This is called markup. So how do you get this request? So basically, if you wanted to get this web page, you would send a request to the server which says get, and then you will give the directory name and the file name, and you will give the protocol that you are using. Then you will send the next line. And by the way, HTTP is a protocol that uses ASCII messages, not binary messages. So this thing is in English, alphabets. You can type it if you want to from your keyboard straight. So the first message says GET space / whatever, right? The next message says host, actually not next message, the next line, because this could be all one message. Host : that is the host I want to get to. Connection, close the connection after giving me that. User agent, I am using Mozilla 4.0 and I accept only English. Okay, you send this message and then you send an empty line. Empty line means end of message. So here what we have said is that, the method is get. This is the method I am using. URL is actually, now here's the question. The URL is actually not this one. I think URL I have to use both the host and the directory combined, but anyway, this is the directory part of the URL. The protocol version is 1.1, and the header fields, these things are called header field. Everything before the colon, host, connection, user agent, accept language, those are all the header fields. And there's a colon, real colon there. Okay, so here is the general format. You have to put a method followed by a space, followed by a URL, which is actually the directory name, space, version number, CRLF, carries return and line feed. After that, you have to put the field name, value of that field, CRLF. You keep doing as many fields you want, then you do CRLF. And then if you have something to send with it, then you send that, and then you CRLF. Okay, so this is what the HTTP messages look like. First thing that you learned today is that HTTP does not use binary messages. It uses ASCII messages. And therefore, you can actually, I will show you in a minute, you can type it in. But anyway, this is the response that will come back. The response that comes back will say HTTP 1.1 200 OK. Connection closed, date, server, last modified, content length, content type, and then lots of data. Yeah.
If you create a persistent connection through a terminal or command prompt, when would that close?
Oh, at the same timeout. It doesn't really know whether you're doing it through terminal or you're doing through Internet Explorer. Whatever timeout is set in the server, it will time out.
Even if you were to close the browser to get
Yes, the thing is when you close the browser, the normal thing that the browser will do is it will close all its TCP connections. Right? And so that will close the connection anyway, explicitly. But if you don't request anything, then also the connection can be closed by the server. So any site can close the connection. Okay, so now here's the thing to notice here, that you have the protocol version and then you have the status code. The computers will not read much of this text, but they know the number, that they are looking for the number 200. Okay? That 200 means good. Everything is perfect, no error. If it is 300, that means there is some problem. If it is 400, there is a bigger problem. And 500 is even bigger problem. So 301 means moved permanently, 400 means bad request, 404 means not found, 500, and so there is a whole list of these numbers. So your browser actually doesn't really read OK. If necessary, it might just flash that OK on your screen, or it might flash this message bad request on your screen or not found on your screen. So that text is for the user. The number is for the browser. Right? So the browser sees the number and then it thinks, then it knows whether it succeeded or failed. So that number is important. And those numbers are very properly set. All 200 series is good, all 300 series is bad, 400 is more bad, and so on and so forth, right? All right. So 200 is the best number you can get. Is that clear so far? And these things are very similar. Those something colon is again header field, and then the value header field and the value carries return here at the end, and then data and carries return. So a blank line ends the header, and then the blank line ends this thing. Again, the message format is same as before. First the version number, followed by space, followed by status code, followed by space, followed by a phrase, followed by carries return line feed, and then the header field name, space, value, carries return line feed, and so on and so forth. Okay, so this is the message format. Now you can do it on your computer. What you can do it when you go home, you can try this out. And I did this yesterday, so you can see right here, 13th September. You can sit down on the computer and say telnet www1.cse.boostel.edu port 80. So what you are saying is that I want to connect to this computer on port 80. Then you can say get/join sample stm http/1111. You have to type all this. Now here's the difficult problem. When you type all this, none of this is echoed. So you won't see anything on the screen. It's like your password. The reason it is not echoed is because the web server is told not to echo anything. It just basically, echoing comes because normally when you put something in the computer knows that it has to echo it. It does it, right? But this one is not echoed. So you won't see anything. You just keep typing blindly. And hopefully you type it correctly, because if you make a mistake, you don't know what you typed. Right? One way to avoid that mistake is to put this into the, what they call in the, when you copy something, it goes into, yeah, clipboard, and then just paste it. And you know how to paste it in DOS, in a DOS box, in a command prompt. Okay? So you just paste it, and then because you already typed it beforehand, and then it will be correct. And that's the only way to do it. All right, so you type this, and then you put a space, line written like that, host, and then that's it. And then suddenly you will see this appear on your screen. What will appear? HTTP 1.1 200 OK, date, server, accept range, bytes, content length 233, connection close, content type text HTML, character set this and that, and then HTML head body. This is sample text body HTML. So this file does exist. I prepared this file just for you guys. So this file exists, and this is what this file has. All it has is these 5-6 lines, right? And if you count the number of characters, it is 233. Okay. Now you don't have to go to my website or anything. You can just go to any website. You could go to google.com, you could go to amazon.com, and so on and so forth, and same thing will work. You could go to woostel.edu. All right. But the interesting thing to notice is that these are the messages, and that these are ASCII messages, and therefore you can type it. And that was the whole reason for having ASCII messages. Before this, most of the other protocols had binary messages, like TCP, everything binary. IP, everything is binary. All the old protocols were in binary. And the reason was we were trying to save every bit. But now we don't care for the bits, we care for readability, we care for easy debuggability, so it is much easier to debug with ASCII, human readable messages, rather than computer readable messages. So most of the newer protocols that we use ASCII messages. All right. Any question about HTTP? All right. Now, if this text was given to a browser, all you will see on the screen is this is sample text. That's all it will show you, right? Because the browser knows how to read HTML and how to present it on the screen. All right. Now you could do this. You could say telnet and get Giants 473-08 step 11. If you go to 08 sample.html, you will get this thing. All right. This message says HTML head 404 not found, blah blah blah. So this is all comes from the server, the doc type and so on and so forth. And then the browser will translate that into a screen message like this. Not found, the requested URL sample.html was not found in the server, Apache, blah, blah, blah. Okay? So when something doesn't exist, the server makes up a response. Is this clear? All right. So now we talk about cookies. So why do we need cookies? We need cookies because the servers do not keep any state. Now, if there are many people reaching the server, they might be from the same IP address, same so on and so forth. We need to know actually what you did before so that we can tell you what to do next. You want to keep the state, so then people invented cookies. So what cookie is a number that is kept on both sides. So for example, when you go to eBay, and you send a, let's see, if you send a, let me put it this way. If you are a client and this is a server, if from the client you send a usual HTTP request to the Amazon, then what Amazon will do is it will create an entry that Mr. Jain logged in at this time, and it will send you a message which has all those previous things that we saw, plus it will have one more header which says set cookie to 1678. All right, and your browser will remember that Amazon sent me cookie 1678. It could have similarly gone to eBay, and eBay would have given it 8734. So there is a whole directory, which is this directory in my case, C:document and settings Raj Jain cookies. You put your name there, go to your computer, and then in that you will find lots of files from many different websites that you have visited in your lifetime. Right? Everything is there. Everybody sends you a cookie and it's all documented right there. So in that directory, all these things are stored as separate files. Or could be one file. That is up to the browser actually. So next time, if you have a cookie, you have to send it back. So the browser, when next time when you send the request to Amazon, then the browser will say, here's my request, and by the way, the cookie is 1678. All right? Then it will know, yeah, you are the one who came 2 days ago and you were looking for a computer or Mac or Apple, and things like that. Then it will know all about your history. Yeah.
Is the client side only just storing that, actually just storing that one number, just the ID?
Okay, so the question was, does the client side just store one number? Here I'm giving an example of a simple one number, but it could be a big number or a big text. It could be 2,000 words. Depends upon, the thing is they want you to store something that when you send it back to them, they will figure out the whole thing. It could be a very small number, could be a big number, could be a big text. But something that both sides will understand. I mean, actually, hold on. The client doesn't understand anything about the cookies. Client doesn't know what 1670 means, but the server will understand that. Okay, so it doesn't have to be just one small number. Some cookies have everything stored. So for example, in this case, the Amazon has to have a disk on which they have stored all the cookies they have given to the world forever, right? Right? But that's not a good idea. So what they will do is, they will, in the cookies, they will say cookie, Raj, Jain. And so everything that they need to know about me is in the cookie. And when I send it back, I send it the whole thing myself. I'm telling them, okay, Raj Jain, I came on December 22nd and I looked for this. All that is in the cookie. Cookie could be a whole big file. All right, so cookie is some piece of information which allows the server to somehow get back to the previous state. And then it will give you the response. All right, when you go to eBay, you take their cookie and send it to eBay. So whichever computer you go to, your browser goes into the cookie area and first looks up and sees if you have cookie from that website. If you have, it sends it. Even if you go up after 3 days, 5 days, 1 month. First thing the browser does is it looks up the cookie. And you can delete the cookies. So for example, if you delete the cookies, no big deal. The browser will not send anything, and then the Amazon will not recognize you. And then particularly if it is your bank, it will come up with a message that this computer we have never seen before. Please reauthorize yourself. What was your mother's maiden name? Right? And then you have to answer all those 5 questions, and then they will put the cookie in. Right? So you understand the purpose of cookies. Proxy servers. So it so happened that everybody is going to the same website and accessing the same information. So some companies thought that why do we have to waste time getting the same information 15 times over the internet, because everything costs money. So they said we will put a server right here in our company. That will provide the answer to all the requests that you might want to get if it has. So it will cache the answers. It will cache the web pages. And if it doesn't have it, then it will send a request and get it, and then remember it, if somebody else wants the same web page, it will give the answer right from its cache. So that is called a proxy server. This is the origin server, This is the proxy server. Origin server is the original piece of information, but the proxy server caches that information, and so if this client wants it, it gets it. For this client, it just serves from there. Yeah.
What's the difference between that and just adding another server?
Oh, this belongs to the company, this belongs to the Google or Amazon or something like that.
So the proxy server belongs to the client.
Yeah, this belongs to Wushtel, for example. Because Wushtel is paying for all these messages going out. Any other question? Yeah.
How often does it get clear its information?
How often this clears information? This is all basically, huh?
If the web page were to then change to them getting old data.
Okay, so it will. So here I think this is all up to the person who is managing the web server, proxy server. They can put the timeout, clearing policy, and all that. Now, you as a client have the right. You could say here a message request which says, "Please reload it fresh." So there is a reload button on the browser. If you do that, then it will say to the proxy server, "Please get it directly from the origin server." Then it will go and get it, the latest information. Otherwise, you keep typing that page, it comes back to the same old information because you didn't tell it explicitly that you wanted it from the origin server. So have you gotten into that trouble sometimes that the page looks old and then you have to reload it? Right?
Well, does that caching also happen on your own computer? Like on the
Exactly. So there is a proxy server right on your computer as well. So this computer browser has its own cache. And first thing it does is it looks up in its own cache. If it has the information, it puts it right there. If it doesn't find it, then it sends the request which might be kept by the, now here's an interesting thing. This proxy server has two purposes. First purpose is to filter out the request. If you type XXXX something, the proxy server says, sorry, information is not available, is not allowed. In this company, you cannot go to XXXX. Period. Right? So any kind of control that the company wants to put can be put into the proxy server. So in many places, it is compulsory that you cannot do anything going out of the company without going to the proxy server, even FTP or anything like that. For example, in many universities, I have been to one university where I had to program proxy server in my computer because they didn't want you to go to places that they didn't want you to go to. Period. Yeah.
So that means like your company had a proxy server that blocked that. There's another proxy server, you could request to go to that server?
No, well, sitting is you cannot get out of the company. Sitting is if this proxy server is inside the company, this other proxy server is inside the company, then yes, you could get out through that door. But this is almost like a firewall now. So the proxy servers and firewalls kind of, start coming together. Originally, the proxy server were for performance, so that you didn't have to waste money. But then people said, well, this is a good firewall as well. So, does it answer your question? Yeah, if you want to use some proxy server in some other university, you have to get out of this university first. How do you get out of this university?
Like they'd also have to specifically block that one too,
They would have to block. Yeah, see, generally what they do is, if it is, we'll come to firewalls later on. So I don't want to go into much detail, but firewalls will look at many things. They will look at the addresses, they will look at the port numbers, they will look at the protocols, and they can block anything, whatever is programmed to block. So they could have blocked that any port 80 request is blocked unless it goes through this. All right, so now you know proxy server. Then they invented conditional GET. Conditional GET says that please get to it to me if the information has changed. If it is not changed, don't send me that 2 megabyte file. Just tell me that it has not changed. So conditional GET is if modified since this date. So your request will have GET, and then you will have this header added, if modified since. And you put a date, and then you go to the server. Server will check if the date, if this object has been modified. If it is not modified, it will say, sorry, 304 not modified. And if it is modified, then it will say, here, 200, okay, here's the data. Okay, so this saves quite a bit of traffic. So that ends our discussion of HTTP. HTTP is the Hypertext Transfer Protocol. It's a client-server protocol. And so important thing is to notice that it is not P2P, it is client-server. Second thing to notice is that it is text-based messages, things that you can type and read. Third thing is they are written in HTML and uses non-persistent TCP connection generally nowadays. It uses cookies so that the servers can maintain a state, and proxy servers are used to improve the performance, and then the conditional GET improve the performance even further. Okay, any questions? It's all clear? Okay. So we move on to homework 2A. So this is the output of something, and the question you have to say is was the server able to find the document? What was the document? When was the document last modified? How many bytes are there in the message? What are the first byte of the document? And did the server agree to a persistent connection? You have to answer those questions based upon this. I will let you read the book and then answer them later on. We will move on to FTP. File transfer and electronic mail, two protocols, FTP and email. And so we'll talk about SMTP, which is the mail transfer protocol, and FTP. And we'll show you how they are different. And then we'll talk about POP3 and IMAP. So FTP is used for file transfer. Some of you might use browser for FTP, and you can just write in the browser FTP : whatever. But some of you might have an FTP client just for file transfer, FTP client. Some of you might just do FTP in a DOS box where you can say FTP program, and then you have to write down GET, put everything yourself. But FTP is a very old protocol, one of the original protocols on the internet, and it is in binary. So you cannot read the messages just like that, bit by bit. Those are bits. But anyway, there are two kinds of, actually FTP sets of two connections. First thing to notice is that it uses port 21. That is what we call the well-known port. But you can, again, just like HTTP, you could design your server so that it uses any port that you want, and then the clients have to ask for that port. And so if client doesn't say any port, then FTP uses port 21. But it uses two connections, not one. HTTP used one connection. This one uses two connections, one for control and one for data. What is data? What is control? Data is the thing that you want to transfer. Control is everything else that the computers have to exchange in order to get you the data. All the overhead messages are control. Okay? All the connection setup messages are control. So it has a separate connection for that, and then separate connection for data. And that means control is out of band. Means control does not use the same connection as data, it is out of band. In band is the opposite of this. In band means data and control use the same connection. For example, HTTP was in band. Alright, control connection is persistent. Data connections are non-persistent. So here, once you connect to an FTP server, it asks you for username, password, and connection is set up until you say quit, bye, or something like that. The connection is there. What connection is there? Control connection is there. Right? Data connection, you say get this file, it will give you the file. It set up a connection, get the file, close connection. So the data connections are non-persistent. And stateful. And the server has a complete state. It knows what directory you are in, what device you are in, and so on and so forth. What is your username? So until you close the connection, the control connection, the whole state is maintained. This is in some sense opposite of HTTP. Okay? And the commands for FTP are, as usual, user, username, password, list. List is simply a command which lists the files directory. Then we have retrieve file name, store file name, status, and then the status numbers are very similar. 331 username. Okay, so they may not be similar to HTTP. So, but so for example here, 331 username. Okay, password required. 125 data connection ready. So there is a number and there is a text. The text is what is presented to you. The number is what these clients and server understand. All right, that's all I'm going to say about FTP. And that's probably the end of the lecture today. But any question about FTP? So Monday we will have the homework due, including 1A, B, C, whatever. A was done already, B and C, and then 2A, 3 homeworks.